Welcome to Motras Scientific Instruments. In this video, we will look at the analysis of arsenic using our Atomic Absorption Spectrophotometer, AAS+. The analysis will be carried out using hydride generation technique. The Hydride Generator is our in-house developed model 1200 ET. This model uses ElectroThermal method to heat the hydride cell, which enables very high stability of the results. The Hydride Generator works on the following principle. Sample is injected into a mixing cell with reagents, hydrochloric acid and sodium borohydride. There are two peristaltic pumps in the instrument to carry the sample and reagents independently. The peristaltic pumps are individually controlled, allowing user to precisely set the ratio of the sample with the reagent. The vapors of this mixture is then pumped into the heated cell using inert carrier gas such as argon. As this vapor passes through the cell, the Atomic Absorption Spectrophotometer records the signal in term of absorption. The absorption signal is linear with respect to the concentration within the sample. As you can see, the Atomic Absorption Spectrophotometer is set up with autosampler and has integrated touchscreen which runs Microsoft Windows 10 based application. This is the hydride cell which is heated electrothermally. Here you can see the hydride generator with independent peristaltic pumps. In the background, you can see our fully automatic gas box, however we will not be using this in current setup. The cell is connected with the hydride generator. This is the integrated touchscreen data station running Microsoft Windows 10. We will now see the lamp installation. We will be using our arsenic lamp for this demonstration. The lamp parameters are listed on the lamp itself for quick configuration. We will now see PC connection with the instrument. We will be using Wi-Fi connectivity to connect the PC. The Wi-Fi connection is activated and the IP address of the instrument is noted. Please note the touchscreen even works with gloves. The instrument's IP address is entered in the application window and the connection is successful. The automatic turret position is set to park mode for lamp installation. The lamp is automatically positioned for analysis after installation. Here you can see the automatic turret selecting the arsenic lamp for analysis. We will now follow the SOP provided in the software for setup of hydride generator. The arsenic element peak is plotted in the first step. The instrument is set as 0 as second step. Once this is done, the cell heater is enabled. The heater is switched on and the current setting is indicated on the front panel. The hydride generator has precise controller for heating which can be adjusted as per analysis requirement. In this case, we will set it as 150 volts. The cell is heated within 3 to 4 minutes. Once heated, the cell looks like this. The peristaltic pumps are enabled using the toggle button on the front panel. This will start both the pumps in a synchronized way. This is important so that there is always positive pressure coefficient within the reagent and sample pipes. You can see the reagents flowing through the tubes here. As the cell is heated, there is a rise in absorption. This is due to background and heat wave produced within the cell. However, once the cell is saturated, the rise in absorption will stop and the system will reach equilibrium. Once equilibrium is achieved, argon is enabled and purged with flow rate to compensate for the heat wave generation. Now the system is ready for stability test. During this test, we will use 40 ppb standard. We will run the standard once and see the maximum absorption. Once the maximum absorption is recorded, we will run blank to see if the system returns to zero absorption. We will then again run the 40 ppb standard to see the maximum absorption. The absorption should be same for both of the runs. In the first run, the absorption is reported as 0.136. As we are not targeting the sensitivity, we should be okay with this reading. Also, the blank is reported as near zero, which means that there is no contamination or sample left over within the system. Again, we are not targeting the lower threshold, thus a reading of 0.007 is fine. Later in next video, we will see this as complete zero when we plot a linear graph. We again run the 40 ppb standard to see the reproducibility of the system. The second run gives us the absorption as 0.135, which matches with the previous reading of 0.136. This shows that the instrument is highly stable and repeatable even in the case of hydride generation analysis, which is one of the most complex tests in any atomic absorption spectrophotometer. The level of repeatability is unseen in most systems, while we are able to demonstrate this over and over again. Thus, to conclude this video, we have seen the setup, control, SOP and repeatability of Atomic Absorption Spectrophotometer, AAS Plus, and ElectroThermal Hydride Generator, ET1200. In the next video, we will make a linear plot of arsenic standards and read some unknown samples. Thank you for watching this video. We hope this helps you in your analysis.